Note 7c, Inverse Functions. Example 1. Find the inverse of each relation. We have 4 ordered pairs, x and y. The inverse means the opposite. So recall from notes 7b, the opposite of addition is subtraction, the opposite of multiplication is division, the opposite of a power is a radical, and the opposite of an exponent is a log. So if we switch these, now we're going to have y comma x. So we just switch the numbers and write it out. We have 3 comma 10, negative 4 comma 7, 20 comma negative 8, and then 2 comma 2. B, we have x and then we have f of x. To get the opposite, f inverse of x, we're just going to switch the x and y values again. So we have negative 1, negative 2, 1, negative 1, 3, 0, 0, 1, and 7, 2. The steps for finding an inverse of a function. You will replace f of x with y so it's easier to write. You will switch the x and y in the equation, solve the equation for y, and then replace that y with f inverse of x. Basically what you're doing is solving for x, and x is now the output instead of the input. Example 2. Find the inverse of the functions below. A. F of x equals 2x minus 5. First, let's write y instead of f of x to make it easier to write out each time. Let's switch the x and the y around. You could actually do that in any step, but we'll do it for step B. Solve the equation for y. We add 5 to each side. X plus 5 equals 2y. Divide each side by 2. So we have 1y equals x plus 5 all over 2. So your inverse function is f inverse of x equals x plus 5 all over 2. B. F of x equals x minus 3 all over 5. Replace f of x with a y. Switch the x and y. Get y by itself. First we will multiply by 5 each side. And then we will add 3 to each side. So then we have y equals 5x plus 3. So our inverse is f inverse of x equals 5x plus 3. C. F of x equals 2/3 x plus 7. Let's write y equals 2/3 x plus 7. Switch the x and y. And then solve for y. Subtract 7 from each side. And then multiply by the reciprocal of the fraction, 3/2. So then we have y equals 3/2 x minus 21 over 3, or 21 over 2. So our inverse is f inverse of x equals 3/2 x minus 21/2. Example 3. For each of the following functions, I, graph the given function, I, find the inverse, I, graph the inverse, and IV, State the domain and range of the inverse. Let's look at A. f of x equals x squared minus 3. So first we want to graph the given function. So from the parent function x squared, it looks like it goes down 3. And we'll do that in this color. So we'll plot each point and then connect the points. We're going to find the inverse. For quadratics or any even degreed functions, you'll actually have two possible inverses depending on what the restricted domain is. Since it doesn't specify, we'll write one in each color. So let's find the inverse. So we have x equals y squared minus 3. Add 3 to each side. X plus 3 equals y squared. Take the square root of each side. You could have a plus or a minus here. So you would have two different possibilities depending on the domain. So then you have y, or f inverse of x equals plus or minus square root of x plus 3. So let's do the positive one first. So it looks like it's going to go to the left 3 for the origin. 1, 2, 3. And we'll go ahead and plot that on our graph. If it doesn't specify a restricted domain, they usually have you just choose the positive one. But if we were to find the negative one, it'd look like this. And you would have a parabola that's opening sideways. Notice it would fail the vertical line test if you try to use both at the same time. That's why you have to only have one at a time with the restricted domain of your original function. So the domain of the red one, the positive square root of x plus 3, would be from negative 3 to infinity. And then for the blue one, the domain would also be from negative 3 to infinity. The range will change though. The range for the positive one is from 0 to infinity. But for the negative one, you'll have negative infinity to 0. So for the negative portion, the original function needs to have a restricted domain of negative infinity to 0. And then if you were to have the positive part, the restricted domain would need to be from 0 to infinity. So for the inverse, the domain and range are opposite of what they were for the original. So this is the range of the original function. This is the restricted domains of the original function. Let's look at B. Y equals x plus 1 squared. So let's graph this. From the parent function, it looks like it goes to the left 1. And then we could draw our graph. Okay, now let's find the inverse. So we have x equals y plus 1 squared. Let's exponentiate each side by 1/2. So we have square root of x equals, and remember we have a plus or a minus, y plus 1. Subtract 1 from each side. So f inverse of x equals plus or minus square root of x minus 1. Let's do the positive one first. So it looks like it went down 1, and then we can draw our graph. The domain of this one is from 0 to infinity. The range of this one would be from -1 to infinity. Okay, let's do the negative one. We'll graph that. The domain is the same, 0 to infinity. Our range is different though. It's going to be from -infinity to -1. Our restricted domains of f of x is -1 to infinity and then -infinity to -1. Let's look at the last page of these notes for 7c. Inverses of linear functions. So, if you look at it, inverses are symmetric with the line y equals x. So if we were to draw a line right here, you would notice that each of these halves of the line has equal parts. They're symmetric with each other. If you look at the graphs and they're symmetric with each other and both of those graphs are functions, then that means they're inverses of each other. If you look, like for example on the previous page, they're symmetric here, but they would only be considered functions if you had that restricted domain. Same thing with this other one. They're also symmetric here. So let's look at the linear functions. So we start with f of x equals mx plus b, where m and b are just some numbers that they give you. The inverse would be f inverse of x equals x minus b all over m. Basically, you start with a plus b on the outside and you end up with a minus b on the inside at the top. Instead of times m, you're going to divide by m. Let's look at this example right here. We have f of x equals 3x minus 4, and the inverse is x plus 4 over 3. We just plug in those numbers. Now to solve this algebraically, we would just do x equals 3y minus 4, solve for y. X plus 4 equals 3y, divide each side by 3, and then you have f inverse of x equals x plus 4 all over 3. Inverse of power functions. These would include quadratic and cubic functions as well, or any number right here to raise that power. So we're given f of x equals a times x minus h to the d power plus k. The inverse would be f inverse of x equals the dth root of x minus k all over a plus h. So if we look at our example, we have f of x equals x cubed minus 1. In this case, k was a negative 1 and the d was 3. The opposite of a cube is a cube root. The opposite of a minus 1 on the outside is a plus 1 on the inside. Here's how you would solve that algebraically. So we're going to switch the x and y, and we'll call f of x y instead, so we don't have to write that whole thing each time. Add 1 to each side. X plus 1 equals y cubed. To get rid of a cube, we'll exponentiate each side by 1/3. 1/3 is the same thing as a cube root. So we have the cube root of x plus 1 equals y, which will be f inverse of x. So if you look at the graph right here, they're symmetrical with this line y equals x. Let's look at inverses of radical functions. So we start with the radical and then we go to the power. It's the opposite of right here. So we're given f of x equals a times the rth root of x minus h plus k. And then the inverse would be f inverse of x equals x minus k all over a to the rth power plus h. So the opposite of multiply a is divided by a on the inside. The opposite of rth root is a r power. The opposite of a minus something on the inside is a plus something on the outside. And the opposite of a plus something on the outside is a minus something on the inside. Let's look at the example. F of x equals the cube root of x minus 1. And then the inverse is x cubed plus 1. Here's how we would do that algebraically. So we have x equals the cube root of y minus 1. To get rid of a cube root, we'll exponentiate each side by 3. So we have x cubed equals y minus 1. Add 1 to each side. And then you have x cubed plus 1 equals y, which we'll say is f inverse of x. Okay, now let's look at inverses of exponential functions and logarithmic functions. So we're given the function f of x equals a times b to the x minus h power plus k. And then the inverse, the opposite, would be f inverse of x equals log base b of x minus k all over a plus h. We're given the example f of x equals 3 to the x power. The opposite of that would be f inverse of x equals log base 3 of x. Here's how you would do this algebraically. So we switch x and y. We'll call f of x y. And we have x equals 3 to the y power. To get rid of a base, we want to log with that base each side. So log 3 each side. That makes this go away. And then you have y equals log base 3 of x. And that's the inverse, f inverse x. If you look at the graph over here, we have a symmetric image with this line. So those are inverses of each other. Now let's do the opposite. If we start with a log, and the opposite would be an exponent. So we're given f of x equals log base 2 of x. The inverse, f inverse of x, would equal 2 to the x power. Here's how you do this algebraically. So we switch the x and y. We call f of x y. X equals log base 2 of y. To get rid of a log with a base, you're going to base each side with whatever it says here. Log base 2 2 to the log base 2 would just be 1. Those cancel out. So you have 2 to the x power equals y. That's your inverse function. Try the practice after you've completed these notes. And then do the Canvas quiz.